Okay. Thanks for attending the evening talk on thank you. Thanks for attending the evening talk on climate change and the carbon footprint reduction in structural engineering. Climate change and the carbon footprint has been very hot topics recently worldwide. In front of the Mother Nature, mankind are tiny and fragile. We heard too many news on flooding, hurricane destroying homes, forest fire chasing away families, tsunami wipe out beach villages, glaciers melting, and global warming, etc. Although humans are small in front of nature, we have yet requested a lot from the nature. For natural resources, closest to where to live, to feed, to stay, and enjoy a better life. All these activities causes emission of CO2 to the atmosphere, use up of precious natural resources, and the leaving irreversible footprints and wounds to the earth, which raised us. As an engineer, what shall we do in return to the nature, and what shall we leave to the grandchildren after decades down the road? IES I-STRUCE Joint Committee had the honor to invite our distinguished speakers, Mr. Will Arnold from I-STRUCE UK, Ms. Vun Ching from Singapore BCA, and E.R. Joe Lam from Arab Singapore for the talks on climate changes and carbon footprint reduction in structural engineering. Please allow me to introduce our first speaker, Ms. Will Arnold. Will Arnold is the head of Climate Action, the Institution of Structural Engineers, United Kingdom. Will leads the institution response to the climate emergency, leading activities across the institution to put sustainability at the heart of everything we do as structural engineers. His main focus are on resetting the requirements of professional engineers, upskilling the engineering community to respond to the current needs of the world. Previous to his work with I-STRUCE, Will was a practicing engineer at Arab for 10 years, where he was responsible for key aspects of ambition architectural projects across the world. In 2021, Will was presented with the President Award by the institution in recognition of his work in instigating change in the fields of structural sustainability. Today, his topic will be structural engineering and climate emergency. Let me just to mention, there will be a Q&A session after each of the speaker. So you may post your questions through the chat so everyone can see, and our speaker will pick up your question through the Q&A answer session. Thank you. Now I hand over to Mr. Will. Will, now to you. Thank you.
Oh, apologies. Let me just reshare that. We can do all the rehearsals you want. It doesn't mean it'll go right on the day, does it? 1 second. Okay, GNN, can you give me the thumbs up if you can see my screen? Okay.
Yes.
Okay, perfect. Thank you, and apologies for that awful start. Thank you for inviting me to speak. It's really nice to be able to speak to people around the world on this topic, and it's one of the advantages of Zoom and the way we sort of work these days is that it's seamless to be able to do so, and it's amazing to see such a big turnout at this event as well. 100 people in the room listening now, so good to see that this topic is being given the attention that it needs. So yeah, as Gian said, I'm head of climate action at the Institution of Structural Engineers. I'm based in the UK, but like I say, I do quite a few of these sort of talks in different parts of the world from time to time. My work is based around everything we've got to do to help practicing structural engineers respond to the climate emergency. So I'm looking at what we do in terms of the requirements to be a structural engineer with the institution, but also how do you generate the right sort of guidance to give to people so that they can then, change the way they go about their own work. And hopefully in my talk for the next 20-25 minutes, I'll be able to take you through some of those thoughts. I'm going to start, as I do with all of my talks, by just setting the scene. And I'm aware that a lot of you probably don't need to hear this, again, because you know that we have a bit of a problem, but I always think it's good to recap and just to refresh our memories. And this also might be useful to you because it might give you some things that you can say to your clients or architects or other people who you want to speak to about this topic as well. So I think that the real game changer, the point when people started listening and realizing, on a wide scale that we have a real problem that needs tackling, was when this report was released in 2018. So this is the IPCC report on global warming of 1.5 degrees C. And the IPCC is a group of about 500 or so scientists from around the world. And they published this report in 2018, which included these words. So it said that rapid, far-reaching and unprecedented changes are required. And when they say that, they are referring to the amount of change we need if we're going to limit global warming to 1.5 degrees C, instead of allowing it to rise beyond that point to 2 degrees C or even further. And those are words that we hear quite a lot, particularly during this pandemic. We've heard those words quite a lot. But I think we can, we agree, scientists, economists, politicians, they all agree as well that, climate change really is on a scale even bigger than COVID in terms of the disruption that it can cause to our lives if it continues unabated. And so these words that the IPCC wrote in their report, they are not an over-exaggeration by any means. The reason why they said that in their reports is to do with this graph. So this shows humanity's carbon emissions over the last 60 years. This line is not cumulative, okay? This shows emissions each year. So in 1980, we see that we emitted nearly 20 billion tons of carbon dioxide into the atmosphere. By the year 2000, 25 billion, and we are now nearly up at 40 billion tons. And that's per year. So that's going up and up and up, staggeringly fast. And despite these summits between major world leaders happening, nothing's really changed since this topic started being known about. And in fact, if you take the first global summit on this graph, which was Rio in 1992, and you add up all of the carbon emitted since then, so that's the area under the graph after 1992, that totals more carbon than everything emitted before 1992 back to the dawn of humanity itself. So we have emitted more carbon into the atmosphere since 1992 than we ever managed to do before it. That's despite the fact that since 1992, we've known the damage that it's causing to do this. So we've put more carbon into the atmosphere knowing about the consequences than we ever managed to do in ignorance, which isn't very good. We also know what needs to happen next. So if we want to keep global warming within 1.5 degrees C, or give ourselves a good chance of doing it, we need to halve our emissions by 2030, which puts you about here, and then we need to get them down to 0 by 2050. People talk about net zero. That's when the emissions that we put out into the atmosphere are balanced by things that can absorb carbon from the atmosphere. So that's trees, that's the sea, the wildlife in the sea, that's carbon capture. Those two things need to balance by 2050. But what it more or less means is that actually we need to emit almost 0 emissions in the first place by 2050, because those things that can reabsorb carbon are on a pretty small scale and are likely to stay on a small scale going forwards. So we have about 28 years to get emissions down to 0, and we only have 8 years to get them down to half, get them down to 50%, which is not very far away. 8 years, unless you're planning on retiring in the next 8 years, this is going to be a very key part of your job going forwards. And we're seeing countries around the world responding to this. This diagram shows countries that have net zero law in place in green. So those are countries where they've said by 2050 or 2040, 2060, we will be a net zero carbon country. Those shown in orange are countries where they have official government policy to the same effects. And those in red are countries where they've started the conversation around enacting those policies. And whether you agree with the details of any particular country or not, it's all going in one direction. This graph is going to get more and more orange and then more and more green, which means that whether you are designing projects in Singapore, in other parts of Southeast Asia, or even on the other side of the world, South America, say, or Europe, it doesn't matter. At some point in the next few years, you should expect those countries are going to start having law in place that means that they have to get down to net zero. It's only going to go in one direction. So we will have to get used to designing in a way that responds to those legal requirements. Okay, that's what the science and the law tells us about what needs to happen. But why? Why does this matter? What happens if we fail to stop global warming at 1.5 degrees C? Because 1.5 degrees to 2 degrees, that's quite small, right? It's actually not. I mean, it's a really big difference. So at 1.5 degrees, flood risk around the world doubles, 100% increase over where we are today. At 2 degrees, it practically triples. It's nearly triple. At 1.5 degrees, nearly 700 million people, so that's the same as all of Southeast Asia, are exposed to heat waves so severe that people die due to them. And that's every 20 years. So it's not once in a lifetime, it's 3 times in a lifetime or 4 times in a lifetime. But at 2 degrees, it's 2 billion people. Okay, that by this point in time, that will be about 1/4 of the world, half of Asia. Half of Asia will be exposed to these heat waves 4 times in their lifetime. That's what happens if we only get to 2. If you get to 3, it gets worse, right? Now, those predictions are for the year 2100, which is at the end of the century. To avoid those, we need to get emissions down to 0 by 2050. That's not so far away. 2100 sounds quite far away, but it's actually, even that's not very far away either, right? To give you some context, this is my nephew. This is my brother's son. He's called Bobby. Baby Bobby was born in 2019, so 2 years ago. That means that what we're talking about are things that are going to happen when Bobby is 80 years old, 80. That's old, but it's not that old. He'll probably be retired. He might be a grandfather. He might have his own grandchildren. I'm sure that you can think of somebody as young as Bobby. And I just want you to close your eyes for a second and picture that person on their 80th birthday, surrounded by their friends and their family, celebrating their birthday. And imagine the world that they are now living in, because that's a world that we will have left behind for them. And we have a choice about what that world looks like. So every decision you make from now on your projects, those decisions are going to affect that world that that person lives in at the age of 80. Just bear that in mind through the rest of this talk. You can open your eyes again now, if you haven't done already. So, okay, good news now, because that all sounds quite horrible and daunting. So the good news is, as a structural engineer, actually our potential to make a difference is really, really big. It's very significant. Buildings and construction globally contributes to about 40% of energy-related carbon emissions. So that's the biggest piece of this pie chart. And then the next biggest piece is industry and infrastructure. And we have a bit of a foot in that as well. Put together, structures, so the construction of them, the creating the materials, transporting them to site, erecting them, cranes, all of that kind of thing, maintaining them and demolishing them, around the world, that adds up to 10% of all global emissions. 10% of global emissions are structures, okay? That's what we control. You are in a completely unique position. I do not think there's another profession out there that controls so much of global emissions through such a small group of people. Obviously, it depends how, what type of building you're working on, right? So that 38% buildings and construction, you have embodied carbon, which is the construction materials. That's what I just talked about. That's the structure, 10% on average of global emissions. You also have operational carbon, that's your air conditioning, your water, your lights, your heating, things like that. if you're designing a high-rise, low-energy apartment building, it's mostly going to be embodied carbon, which means that your influence as a structural engineer goes up and up and up. It's even bigger now. Obviously, if you're doing something different at the other end of the scale, low-rise, something energy-intensive like a hospital, the balance is tipped, but we still have a role to play. And we also have a role to understand what our colleagues who work as services engineers dealing with HVAC, things like that, what they have to do as well. But embodied carbon is important for more than just the reason that it's a big part of the total. It's also important because these are emissions that are going to happen today. So now. So we are in a climate emergency now. These are emissions happening now. They're not happening in the future. So that's why we're talking about this. On this graph, 2 years of construction emissions, adding up to 40% of the total emissions of this building that I've shown. So this is the building through its life cycle. That is by far the biggest piece of the pie, okay? 40% of the total in 2 years, huge amounts of carbon dioxide going out into the atmosphere. Every other year afterwards is much smaller. And actually, as the electricity grids decarbonize and we get more solar power, wind power, tidal power, this goes down and down and down until eventually buildings operate with zero emissions. Building it, you've already built it. That carbon's gone out, you can't get it back. And typically, out of that, 2/3 of that is the structure. So again, the structure alone is the biggest piece on this graph by a long way. And that's your job, that's your responsibility. Now, I want to put that into a number, just for comparison's sake, because it's useful to put a metric to this. So for comparison, a one-way flight from Singapore to Sydney, and we're going to travel economy class because we're engineers and we don't get paid enough, that emits about 1 ton of carbon. So if you can avoid flying to Sydney, you save 1 ton of carbon. And a ton is quite a lot. You can't pick up a ton of anything. You're not strong enough. So a ton's quite a lot of emissions. If you were to design a warehouse, just a normal steel frame warehouse, the steel structure of that warehouse would emit 5,000 tons of carbon into the atmosphere. This is a very typical project I'm showing on the screen. This was from a write-up that somebody did for me about 6 months ago. 5,000 tons just for the steel frame. That doesn't include the foundations. It doesn't include the slab. It doesn't include the facade. 5,000 tons. And what that means is that if the design could have been 20% more efficient, they would have saved 1,000 tons of carbon. So if there's only one thing you remember from my talk, it's this. There are orders of magnitude difference between the savings you can have in your professional life versus the savings you will have in your personal life. Skip a flight, save a ton. Design something 20% better, save 1,000 tons. It's now your job to go and find 1,000 tons of carbon in every single project you work on as a minimum. It's all out there for the taking. So I'm going to talk to you now for a little bit about what the iStruct is doing about this. Partly just to give you some ideas of the sorts of things you could do on your work, and partly so you're aware of some of the guidance that we have created that you can get hold of, that you can take onto your projects to help you with your work. So in 2019, the iStruct formed a climate emergency task group, and our work falls under these 4 work streams. I'm going to start at the bottom and work my way up because it's a pyramid and we're structural engineers and you build pyramids from the bottom. So work stream 1, setting standards. We revisited the education system. The Joint Board of Moderators, which is the group of people who set the requirements for civil engineering degrees in the UK and in several other universities around the world, those requirements have been updated. Climate emergency as a topic within education is going to grow and become a bigger and bigger thing. Civil engineering students are going to be required to learn about carbon as a minimum, but then they're also going to be required to learn about how you reduce it. We're also updating our requirements to become a member of the Institution of Structural Engineers, and again, that will get carbon at the heart of it. Workstream 2, raising standards. This is about giving you the guidance you need to do that. To date, we've published about 75 guidance articles. Most of them are free, and free even if you're not a member. Okay, so if you're not a member of iStruct, you can still get this stuff, and I'll show you some in a second. We then have our supporting the profession workstream, workstream 3. This is about working with firms. If you work for a major company and you want to get in touch and say, well, what more could we do about this in our company? Just send me an email after this and we can speak. We're always keen to try and help firms with tackling this, because at the end of the day, it's projects that have to change. It's not just people. And then at the top, we have collaborate and influence. And this is why I'm speaking to you today. We are keen to speak to as many different people around the world as we can. It's important that we don't just try and work out our own answers to this, but we share and we learn from each other. There's lots of people doing really good things all over the world on this topic. And it's important that we share those lessons learned with each other so we can do this as quickly as we can. Like I say, we're resetting standards. To give you a snapshot, our chartered membership exam and our initial professional development requirements, they're going to include all of these topics on the side. There'll be more proper announcements about this in the next few months. If you are planning on becoming chartered with the institution, don't worry. We will give you enough time to learn all this stuff. And like I say, the guidance is out there. But we're just starting to give people a heads up that this is going to change in the future. And we've agreed what the changes will be. We're just waiting to communicate that out to people. Guidance, like I say, go onto our website. The web address at the bottom of this page is live. It updates all the time. There's loads and loads of content out there. This is a few of the articles that I just picked at random to show you, but you've got everything from practical guidance on construction materials, all the way through guides on calculating carbon, down to things like circular economy, reuse, stuff like that. So loads of content in there. Do have a look. And again, if you're looking for something and you can't find it, just email me. I'll probably know where it is. Specifically on guidance as well, we created a tool and a guide over the last year that help you calculate embodied carbon. So the first thing we created was our guide, how to calculate embodied carbon. It does exactly what you think it does. And that's downloadable free off the website. So go on there and find it, or stick it into Google. You should be able to find it. We're updating it at the moment, so it's going to have a bit of a revision around about Christmas time this year. But do look at it. It's very straightforward and easy to understand. We then created a tool to go with it, which is just an Excel tool. It's an Excel file that does the same as the guide, but it allows you to calculate the carbon emissions of your projects pretty quickly. So you've got no excuses for not doing it, and it helps you understand where in your project the carbon is hiding. There's no point you trying to get the whole project to be better if all of the carbon is just in the basement. It's worth knowing that so you can make the basement more efficient and just do what you normally do on the rest to start with. Don't forget, if you're going to use these, this is not about calculating it, this is about reducing it. You've got to reduce carbon. Getting the numbers right is only part of this. It's what you do next that matters. There's some links on here to give you some other content from our climate conference that just happened this week and last week. The videos for that will go online soon. And we have videos online from last year as well. So check out those links afterwards. And coming pretty soon, we're talking in the next month or two, we're going to launch a Embodied Carbon Basics course online. So this will be e-learning. You can download videos whenever suits you. So just whatever time of day works for you. When, do you prefer to learn at lunchtime or in the evenings? Whatever, it doesn't matter. A whole series of videos that take you through how to calculate it, what to do with the results of that, what the different types of steel mean, low carbon concretes, all of those sorts of basics. And then next year, we're launching a net zero design course, which will take you all the way through how you design a structure to be net zero. Okay, last few thoughts, because I've only got a few minutes left. And please do, as was mentioned at the start, please do start putting questions into the chat so that we don't lose any Q&A time. And I'll start answering them in about 3 or 4 minutes. Last few thoughts from me. This is about how you design projects and structures that are going to be zero carbon or at least low carbon. The first thing to always mention is, of course, embodied carbon is only one part of this picture. It's a much bigger, complicated, more knotty picture than just that. And sustainability is a very broad subject. Carbon, biodiversity, education, equality, they are all completely interrelated. And the more you read about this, the more you realize you can't tackle one without the other. So you mustn't forget the bigger picture, but you must also remember that as a structural engineer, it's those 1,000 tons of carbon. That's where you have a big, big impact. The other topics on this screen, it'll be more of a personal impact. It's on a project by project basis. But on every single project, you can reduce your embodied carbon footprint significantly with a bit of work. So it's just worth remembering where you are in that big picture. In terms of how you go about reducing it, I think it looks something like this. So these are both sort of hierarchies. Things at the top have the most impact, things at the bottom have the least impact. Start on the left. If you worked your way through the triangle on the left, then you would get to a net zero structure. So you'd use less stuff, use less materials in the first place. You would then specify low carbon and you would offset the remaining emissions. That gets you to net zero. But you'll notice that most of that triangle is use less stuff. And that then has its own hierarchy on the right-hand side. And it's important to see how you go through this. Because if you can make decisions with your architect, with your client, that helps them to reuse things, not build things in the first place, or reduce the size of a building, that will always have a much bigger impact than if you just design, highly utilized structures or you get the configuration right. Now, that's not to say you don't do those things as well, but it's worth understanding what has the most impact and working your way through it. You'll see that, for example, that structural configurations is somewhere in the middle. What I mean by that is, direct load paths, no cantilevers, sensible spans between column grids, really efficient structural design, which is, at the end of the day, what we all like to try and achieve anyway in our work. Most efficient structural design you can get. Then you get onto things like materials. There is, of course, a loop back through this, and as with all design, you loop around this all again and again. So you then decide, well, it's going to be timber. You then have to go back and say, well, what's the right configuration for timber? Because it's different to concrete, and RC is different to post-tension. So, there are some loops, but as a general rule, top to bottom through this gives you the sort of most impact at least. I always tell people, ask as many questions as you can on a project. Ask why the design so far is a new structure. Why are the columns that far apart? Why is the beam or the slab as deep as it is? Does it need to be that thin? Could it be deeper? Would that be more efficient? Basements, transfer structures, materials. These are all questions that just because you come to a project at a certain point in time doesn't mean you can't ask them anyway. And over time, I think over the next decade, our jobs are going to change. People are going to start asking structural engineers more and more, how do I make this more efficient from a carbon point of view? Because your clients will want that, because they will be paid more money by their investors, by the people they rent their office space to, if they can deliver more carbon efficient buildings. So they all come asking for our advice. Don't forget that, of course, if all the wrong decisions have already been made, there's lots of decisions left to make. So you see this graph quite a lot where it says early on in a project, you can have a lot of impact, later on in a project, a lot less impact. But that doesn't mean you can't have any at all. And actually build clever, build efficiently, get the structural configuration right, high utilization, get the materials right, get your serviceability criteria correct. All of those things can help make quite a big difference as well. And you can keep pushing on these decisions right through the project. And this is one of my favorite examples, and this is what I'm going to finish with, just to sort of help reiterate how important it is to keep questioning and keep pushing. So this is a project which a colleague of mine was asked to go and look at after they had finished construction. So this is in the north of London, quite near to Wembley Stadium. So yeah, actually just down the road from the football stadium. And the developer had finished construction, but he wanted to know how much lower carbon it could have been. So he went to this sustainability consultant and said, what could you have changed, but you can't change the architecture? Okay, must look the same. And they were able to prove that with no significant architectural changes, you could save 41% of the carbon emissions on this project through better design, changing the material choices, that kind of thing. And better still, 3/4 of that, 75%, was cost neutral. So they could have saved nearly 30% embodied carbon for free. They just needed to ask the right questions. And there's plenty more examples like this out there where, as long as you keep pushing, you keep saying, okay, could we do better? You can usually find a way to do it, and it doesn't even have to cost any money. In fact, it might save money. The tools are out there. Like I say, go on our website, have a look to see what we've got, and you can always ask me questions as well. You can send me an email anytime. And I've put this in there. I'm not going to talk through this, but I've just put in a couple of links because we have COP coming up in a few weeks' time. It's being hosted in the UK, but these are all events that are being broadcast around the world. I think most of them are free to attend. So do sign up to things and have a listen to what's happening, because I think this will be the most important COP probably that's ever happened. Thank you very much for your time. And yeah, I'm willing to take any questions that anybody wants to ask. So you can type questions into the chat. I can see Professor Locke is typing a lot of things into the chat, which I agree with everything he says. And I think that actually the point in there, that the thing that really stands out to me is the point of demolition, actually, where, yeah, I don't know if this is happening yet in Singapore, but it's something that's very noticeable in London, is that we are having more and more clients say, can we keep the building? Can we reuse the building? And actually my last job at Arup before I left, the client came to us to say, basically, here is my existing building. How much more extensions can we put on top? How many more floors could we put on top of it? And the only job we had to do was work out how much bigger it could get for free. And we saved thousands of tons of carbon doing it. And I think it's getting more and more common, which is really, really good. You find if you're building like if there's already a 10-story building out there, you can probably put 2 or 3 more stories on it without really having to even do too many difficult sums, I think.
Will, I have a question. For UK, is there any platform sharing? Because there's a lot of buildings works ongoing, and there's a lot of experience on the low carbon or carbon footprint reduction. Is there any footprint, recording or database on how it is practiced over the different companies or different zones or countries, how they do the reduction? Is there any good examples or good records? Yeah, thank you.
Yeah, no, it's a good question, Jenna. I think I'll put 3 links in the chat afterwards. So the first is to an event we're holding in 2 weeks' time called the Structural Engineers Declare Summit. And we hold this every year, and we ask engineering firms to come together and discuss how they're managing to, make things better on their own projects and within their own work. And that's available to anyone who wants to come and listen, and it's online. So if people wanted to come along and listen to that and hear some good practice stories, you can. The second link I'm going to put in is for the UK Green Building Council. They're hosting a virtual pavilion at COP. So you can view it from home. I think you might even be able to view it with Oculus goggles on in a sort of VR environment. And you go in, and it's going to have lots of examples of buildings that have been built that you can go and visit in 3D that are, the greenest, the most sustainable buildings in the world. And there's some good lessons learned sort of explained in that. It should be really, really exciting, far better than going to a real pavilion, I think. So I'll put a link to that as well. And the third thing, which probably answers your question the most directly, but isn't yet ready, is something called the Built Environment Carbon Database, which is an initiative being led by the Royal Institute of Chartered Surveyors, the RICS. They are creating a website where once you complete the design of your project and you finish the carbon footprint calculations, you can upload the calculations to this website, and it stores them anonymously, so you don't know whose building is which, but it will tell you this is a 25-story commercial tower, or this is a 4-story educational building. So you can sort of see what sort of carbon footprints are normal and start to understand what good looks like, as it were. So yeah, I'll put all those links in afterwards when we on to the next talk.
Thanks. Well, it's really great information, I think, and the experience to share from your side. So I think it will be very interesting for our Singapore side to also learn how the overseas engineers do the carbon footprint reduction, and there must be a lot of things to learn. Thank you.
The best guides on that, and again, I'll put these in the chat. There's the how to calculate embodied carbon, that's what everybody in the UK is using now to calculate. And we're also releasing another guide this month called Design for Zero, which is about case studies, examples of how you design better, and how much carbon was saved. So you can sign up for that too. I've had two more questions. One of them was direct to me. Do I have time to answer a couple more, Jinan, or do we need to move on?
Sure. Please go ahead.
Yeah. Okay, great. So the first one is from Charles. What have you seen as the most influential changes to get more sustainable buildings? Is it legislation or was it the market? And actually, I'd say that it was a bit of both. So what we've seen in the last 2 years in the UK is very high level legislation. So the UK said we will be net zero by 2050. That's across everything. That sent quite a strong signal because it tells every single business that they are going to have to get their emissions down by 2050. So that's got people at sort of high level thinking about it. But at the same time, there's been a huge amount of work from the industry and from the market trying to do things better. You've got engineering firms wanting to do things better. You've got developers who have realized that actually if they can design more sustainable buildings, it will be worth more money in the future, particularly once in 10 years' time, people are going to look at things very differently to how they look at it today. And so developers and financiers and investors realize this and are pushing us as design teams to do things better now. So I'd say it's kind of coming from everywhere all at once. And I don't think you can just rely on legislation or just rely on the engineers. You need everyone together. But this is certainly what we're seeing in the UK. The other question that came in, which was a direct question in the private chat, was about importing other products. So you don't grow things like much timber or not enough to turn into things like glulam in Singapore. So you have to import them. And a lot of people comment that shipping these products in means more carbon due to transportation. And the question is, what's my view on that? And my view is that if you do a carbon calculation, it will include, or has to include, the transport as well as the products itself. And if you download our tool, it does that very easily for you. I mean, it has on one of the tabs, it has a little calculator for the transport emissions, so you can type in the distance that your wood has come, because maybe it's come all the way from somewhere further up the coast in mainland China, say, but it's come by boat, and it had a bit of lorry to get it to the coast. You put that in, and it will include it in the total. You probably find that it adds 30–40% to the carbon emissions of your timber, would be my guess. But it really does depend on where it comes from. So it's really important that you calculate it, but you can calculate it. It's pretty easy to calculate. And if you use our tool, it will help you understand how much is transport versus how much is the emissions of the product itself. And you can sort of see them side by side. So I'll put a link to the tool in there as well. Quite a lot of links coming up in a second, I think. So I think that's it then from me, Jenna. So shall we move on? I can't remember who's next. You'll have to.
Ms. Vun Ching. Ms. Vun Ching is Principal Manager, Super Low Energy Building Department, Environmental Sustainability Group, Building Construction Authority. Ms. Vun Ching portfolio includes conducting Greenmark assessment and verification under BCA Greenmark scheme, which certifies building on their energy efficiency and levels of environmental sustainability. She is a Greenmark Advanced Accredited Professional, GMAAP, and is involved in the development and implementation of the whole life carbon section. As part of Greenmark GM 2021, with her team members and industry stakeholders, the member of the Singapore Green Building Council, Civil and Structural Technical Committee. Prior joining the Environmental Sustainability Group, she was administrating the regulatory periodical structural inspection of existing buildings, dangerous buildings, and enforcement of unauthorized building works under the Building Control Division of BCA. Her topic today will be reducing projects' carbon footprint through Greenmark 2021 Whole Life Carbon. Let's welcome Ms. Chan. Thank you.
Thank you, Tianhan. Good evening, everyone. I'm Vun Ching from the Environmental Sustainability Group, VCA. It's my pleasure to share with you on the topic of reducing projects' carbon footprint through our Greenmark 2021 Whole Life Carbon. As shared by Will in his presentation earlier, globally, the building and construction sector accounts for almost 40% of the emissions, and this figure is set to rise if we continue business as usual. Hence, there is urgency to reduce carbon emissions if we were to limit the temperature rise of up to 1.5 degrees Celsius. This is a race towards net zero. With the World Green Building Council's Whole Life Carbon vision for total decarbonization of the built environment, the goal is for all new buildings, infrastructures, and renovations to have at least 40% less embodied carbon with significant upfront carbon reduction, and for all buildings to operate at net zero emissions by 2030. And by 2050, all new buildings, infrastructure, and renovations will have net zero embodied carbon, and all new and existing buildings must be net zero operational carbon. Turning the focus towards Singapore, with the timely launch of the Singapore Green Plan 2030 earlier this year, the national sustainability movement seeks to rally bold and collective action to tackle climate change, with concrete plans and targets over the next 10 years that will position us to achieve net zero emissions as soon as viable. One of our key priorities under the Green Plan is to accelerate our transition to a low carbon built environment. And the new Singapore Green Building Master Plan is key to support the SGP 2030 to achieve this movement and meet our international climate change targets. Some ways include increasing sustainability of buildings, towns, and districts by using cleaner energy and increasing energy efficiency, driving research and development in urban sustainability. Given the rising international ambition for climate action, Singapore has announced the long-term low emissions development strategy for 2050 to halve the emissions from peak to 33 megatons CO2 equivalent, and towards net zero emissions as soon as viable post-2050. And the Singapore Green Building Master Plan will play an important role to help Singapore meet its sustainability ambitions and international commitments. The Singapore Green Building Master Plan aims to deliver 3 outcomes in 2030. The first outcome is for 80% of our buildings by gross floor area to be green by 2030. This is not a new target. In the next lap, we want to step up the pace of greening our buildings and look at greening and improving the quality of our building stock, even those that have been greened before, to continue pushing the highest sustainability standards. The second outcome is for 80% of our new buildings to be super low energy buildings from 2030 onwards. We want to mainstream super low energy buildings and have all buildings to be super low energy eventually. And the third outcome is for 80% improvement in energy efficiency by 2030 for the best-in-class buildings through the support for research and innovation and deployment of these new technological solutions to market. Green building is key climate mitigation measure, and our green building journey started since 2005 when we first launched our BCA Greenmark. And shortly after we launched our first Green Building Master Plan in 2006, sand crisis struck when Indonesia banned sand exports to Singapore. Several of the mega projects such as the integrated resorts and Circle Line were affected. The Interministerial Committee on Sustainable Development was formed to formulate and enhance the resilience of key building and construction materials and to reduce reliance on imported aggregates. And a slew of SC initiatives were implemented along the way to support the SC journey for our construction industry, which included incorporating sustainable construction requirements into the Greenmark framework. An ecosystem of check and balance was set up for the construction industry, providing an overall framework of regulatory compliance guided by the adoption of performance standards for the BE sector. Notable ones include the SSEN 12620 specs on aggregates for concrete and incorporating the demolition protocol in SS 557. The Waste Management and Recycling Association of Singapore accreditation scheme was implemented to ensure that the recycled aggregates supplied by the suppliers conform to the specs with quality control checks in place. The certification scheme for the RMC producers, managed by the Singapore Accreditation Council, was developed to ensure that the RMC for structural works comply with the specs of SSEN 206. And of course, we also have the Singapore Green Building Council Product Certification Scheme, which covers sustainable building products and materials for use during construction, renovation, and fit-outs. When Greenmark 2015 and 16 was launched, SC requirements were further enhanced to focus on resource efficiency, recycling, and on carbon, introducing the Concrete Usage Index calculator, adoption of sustainable building systems such as mass-engineered timber and PPVC systems, accounting for embodied carbon of project and the use of low carbon concrete. Fast forwarding to present, we have revamped the Greenmark 2021 and launched our whole life carbon section during the International Built Environment Week last month. And this will be implemented with effect from 1st November, with greater focus on embodied and whole life carbon. Why focus on embodied carbon? Over the years, the industry has established multiple pathways and strategies to effectively lower operational carbon emissions. But embodied carbon emissions are often overlooked. Looking at the pie chart, we can see that the ratio of embodied carbon versus operational carbon is in the ratio of 30 versus 70% currently. However, the importance of embodied carbon grows as our building become more operational carbon efficient with technological improvements. Looking at year 2050, we can see that the embodied carbon will contribute to almost half of the total new construction emissions. Hence, there is urgency to address embodied carbon now. As the Singapore Green Building Council, aligned with the World Green Building Council's whole life carbon vision, has initiated and launched the Singapore Built Environment Embodied Carbon Pledge at the recent SGBC Radars inaugural Green Real Estate Trends Conference in August, as an effort to help unify and amplify industry actions. To date, it has garnered more than 80 pledges from companies, including developers, consultants, manufacturers and solution providers, builders and government agencies who have committed to implementing strategies to reduce emissions in their procurement policies, design and construction, operations and supply chain. If your company has the ambition, intention, or solutions to address embodied carbon emissions, do get in touch with SGBC to join in the pledge. Turning the spotlight to our recently launched Greenmark 2021, along with the 5 sustainability sections, it will provide the framework to work towards decarbonizing projects. And the criteria is formulated and positioned to assist the BE sectors in this transition through its continued emphasis on energy efficiency, which reduces the building's operational carbon and provide recognition to projects which excel in different aspects of sustainability. Now, let me bring your attention to the whole life carbon section in the next couple of slides. The whole life carbon section is outcome-based. It encourages the industry to take a holistic approach in the planning and design of the development, the construction and operation processes, right till the end of life stage and beyond. It consists of 3 modules, which corresponds to the different stages of a building's life cycle. Each module is capped at 5 points to ensure that projects adopt holistic solutions for decarbonization. The first module, CN1, is a new module which recognizes projects for incorporating whole life carbon assessment as part of their design and planning phase, and offers a pathway for projects to demonstrate reduction in embodied carbon emissions of 3 key materials, namely concrete, steel, and glass. It also provides an avenue for firms to take steps to work towards zero operational carbon by 2030 with carbon offsets and renewable energy credits. So when we talk about whole life carbon, what are the carbon emissions that's associated with it? Firstly, we have the upfront carbon, which comprise of emissions from raw material extraction, manufacturing to production, transportation, and construction. Followed by the use stage, which comprise of emissions generated from the use and maintenance of a building over its lifespan. Then we have the end of life carbon, which comprise of emissions from demolition, deconstruction, waste processing, and disposal. Lastly, we also have beyond life cycle stage carbon, which comprise of carbon emissions or emission savings incurred due to reuse, recycling of materials, or emissions avoided due to renewable energy or use of life carbon assessment corresponding to the life cycle stage, and the methodology is consistent with the standards BSEN 15978, BSEN 15804, and the Royal Institute of Chartered Surveyors Professional Statement with adaptation to our local context. The reference period is taken as the default design life of a building of 50 years, which is aligned with the Eurocode SSEN 1990. For the whole life carbon assessment reporting, we require a minimum scope to be included, namely emissions from substructures, superstructure, the upfront carbon, and for the use stage, the maintenance of facade and the replacement of ACMV systems, which give a credit of 3 points. For the full scope of whole life carbon assessment reporting, which covers all other modules besides the minimum scope, an additional 2 points can be scored under the innovation section. For the calculation of upfront carbon, we have the BCA Embodied Carbon Calculator, which enables the project's carbon footprint to be computed. Aside from accounting the embodied carbon of the 3 key materials of concrete, steel, and glass, we also encourage the project team to account for other key materials being used, such as aluminum and timber where applicable. More importantly, projects are required to demonstrate reduction in embodied carbon of the 3 key materials, concrete, steel, and glass across the different building types, with the reference to the baselines indicated in the table here. Projects that demonstrate that they can achieve more than 10% reduction in the embodied carbon will get a credit of 1 point, while projects that demonstrate that they can achieve a more than 30% reduction in embodied carbon will get a credit of 2 points. This exercise also brings about the awareness on how the choice of lower embodied carbon materials can significantly impact the embodied carbon reduction efforts for the project. The second module is on construction, which looks into sustainable construction practices implemented during the construction stage till the end of life of the building, which the industry is familiar with. Enhancement include resource efficiency through low CUI, adoption of sustainable building systems, use of low carbon concrete, replacement of aggregates, use of sustainable products and materials, and conservation, resource recovery, and waste management. during end of life. Let me elaborate in the next few slides. On the design with low CUI, we have tightened the scoring for CUI to a range from less than 0.35 to less than 0.45, depending on the building type. This is to encourage designers to think of more resource-efficient and innovative ways to design the building with the lesser use of concrete where possible. Adoption of sustainable building systems is one way we can reduce CUI of the building. A list of sustainable building systems, which include advanced precast concrete system, MET, PPVC, are just to name a few. And instead of providing a range of coverage for point scoring, we have streamlined to recognize one coverage value for each building type for point scoring. Concrete is a major contributor of carbon emissions. Hence, we have enhanced the criteria to recognize at least a SGBP 2 ticks concrete and above, or an equivalent from the local certification bodies, to be used at least 80% of the superstructure works for point scoring. To build up the resilience on the use of natural resource and circularity of materials, we have enhanced this criteria to recognize the replacement of a minimum 50% granite fines for fine aggregate replacement, in addition to the washed copper slag for point scoring. Under the Conservation, Resource Recovery and Waste Management section, we will give credit on efforts for projects which demonstrate that they are able to conserve some parts of the buildings instead of demolishing them. And in our efforts to salvage more C&D waste for recycling, we have also increased the recovery rate of more than 40% of the crushed concrete waste from demolished buildings to be sent to the approved recyclers for point scoring. The CN3 fit-out section has been enhanced and also incorporated in the whole life carbon section to recognize the efforts on the implementation measures that can be taken by the building owners and the tenants during the building's operation stage, so as to reduce the carbon generated during this operational phase. The measures include the implementation of green lease agreement on environmental building performance between building owners and tenants, the use of sustainable fit-out products for renovation, tenancy offset of operational energy through the procurement of renewables or carbon credits. Next, let us look into the innovation section, which incorporated as a parallel to ensure that the criteria is future ready to adapt to new technologies. As part of the efforts to encourage innovation solutions, the whole life carbon section has a dedicated section for projects to demonstrate unique solutions to enhance other aspects of carbon. These are few examples and they are not exhaustive. One example is the recognition on the use of new sand in non-structural application. As part of NEA's Zero Waste Master Plan, NEA has directed efforts to reduce waste directed to Semakau landfill in a bid to extend its lifespan beyond 2035. One of the strategies include the Project New Sand, where treated incineration bottom ash and slag can be transformed into literal building blocks of lives. From two pictures that you can see here, we can see that the concrete benches on display at the Environment Building and a concrete footpath at our Tampines hub were constructed from new sand. Another example is the use of carbon mineralization technologies, such as carbon capture and utilization technologies. Also recognizing products with environmental product declaration will help to provide an ecosystem for the transparent carbon reporting. For projects that incorporate design for deconstruction in the design to facilitate future recovery of materials, they are also eligible for the credits. Okay, let's move on to the few case studies that showcase the use of recycled and alternative materials and the adoption of sustainable building systems for projects. This is an exemplary project showcasing the use of 100% RCA to construct Samwa's 3-story office and research building, also known as the Eco Green Building, completed in 2010. It was a key milestone towards sustainable development. The RCA was derived from the C&D waste and produced from the company's own recycling plant. I believe some of you in the audience might have visited this building, as it has welcomed more than 8,000 visitors since its opening. For the breakthrough in the construction technology, which has paved the way towards greater sustainability and environmental consciousness in construction projects, it has won the IES prestigious Engineering Achievement Awards in 2015. 10 years on, Samwa continues to push the boundary in the construction of its new Samwa Smart Hub. It was awarded the Greenmark Platinum Positive Energy Awards in 2019, which have incorporated many smart technologies in the building. I will cover the construction aspects of the industrial development, comprising of the 4-story office building and a single-story workshop, which is currently under construction. The project highlights include the use of various recycled materials processed from construction and industrial waste, like sedimentary rocks excavated from the Jurong Rock Cavern, being used to erect the 4-story building. The use of 100% manufactured sand, 100% RCA, GGBS cement, and the use of self-healing concrete at various locations of the buildings. The use of these recycled materials for construction will provide resilience to the limited natural resources and keep the circularity of materials within the ecosystem and also lower the carbon footprint of the building. Next, I would like to introduce you to this project, the Ntu Academic Building South, which is currently under construction. When completed, it will be Asia's largest wooden building at 40,000 square meters, a magnificent timber structure comprising of a 6-story building with a basement. The project has adopted the MET technology with the use of glue laminated timber and cross-laminated timber extensively in its construction, giving it a very low CUI of 0.165. And its high strength to weight ratio makes it easier to handle as compared to steel and concrete. As timber is a highly renewable material, the use of MET contributes positively to environmental sustainability and has a lower carbon footprint compared to steel and concrete. And the use of BIM has facilitated the design, coordination, and clash reduction between MEP versus CNS and architectural components, cutting down unnecessary reworks, material wastage, and unnecessary delays. The project featured here is JTC's Punggol Digital District CC1 Tower 4. It is an 8-story building comprising of a hybrid structural system of mass-engineered timber and structural steel, with the MET contributing to more than 50% of the constructed floor area and structural steel contributing to more than 11% of the constructed floor area. The adoption of this hybrid sustainable system resulted in a low CUI of 0.26. In addition, green concrete mix design was used in the construction, which corresponds to the highest SGBP 4-thick low carbon concrete being used, resulting in the lower carbon footprint for this project. Going forward, we need to further accelerate and galvanize the BE sector's decarbonization efforts. All stakeholders have an important and collaborative role to play to move the construction industry towards a net zero carbon future. Developers and building owners are the needle movers who can create lead demand with low carbon procurement policies and practices. In the view of significance of embodied carbon, Manufacturers and suppliers should take a more active role in the review of manufacturing and supply chain processes towards resource optimization and carbon reduction opportunities. We encourage consultants to incorporate the use of low carbon concrete and alternative materials in the design specs and optimize building designs with efficient resources. Builders play an equally important role to adopt sustainable construction practices and technologies, minimize material usage and waste on site, and increase efforts in recycling. On BCA's front, we are placing greater emphasis on sustainable construction practices requirements through our upcoming revised Environmental Sustainability Code, which will be implemented on 1st December, where projects are required to implement a minimum number of sustainable construction practices to meet the regulatory requirements. We will continue to engage all stakeholders and encourage you to join us in this journey towards a low carbon built environment. To play your part in reducing your project's carbon footprint through the whole life carbon section in our Greenmark 2021, which will be effective from 1st November. With that, I thank you.
Thanks, Vun Ching, for the very educative talk on the BC's direction and the future regulation. May I have the participants, any questions for Ms. Chan? If not, I have one question for Ms. Chan. For BCE, I believe there's a lot of submissions from the industry and projects in the past for various projects like JTC or HDB or other projects, private side. Is there any database on how the different efficiency of the structure system in various aspects as a database, maybe anonymous, can share to the industry so people can know where to have more efficiency or savings to those areas? Will there be any like database, which system will be a better way, or there's anything?
Thanks for the question, Tianhan. Because for Greenmark, right, it's actually a voluntary scheme whereby not all projects will actually come in for submission. Hence, the database that we have is actually for projects which are more aspiring, and then those are the projects that we will actually have the past records of how they actually design their buildings to be more resource efficient. So we do have this database on the scoring, but however, because the criteria requirements that has been put in on resource efficient design actually offers many options for the project team to score. So hence some projects, unless it's for prerequisite requirements, certain projects may not score for, like, for example, replacement of aggregates, or certain projects, they may not score for sustainable products for certain system, like for ceilings or for floor. So, so in that sense, because it is really not a requirement, it's more of a voluntary base. So depending on the nature of the project, they will choose to score their design based on what its intent is. Yeah.
Thank you, Vun Ching.
Does that answer your question?
Yes. Thanks a lot. Any more questions from the floor? Oh, there's one, Mr. Ong Chi. The question is, may I know where do we find a database of Greenmark projects that collected by BCA?
Thanks. My director is here. Thanks, Edward. Yeah, my director, Dr. Edward Ang, is here in our audience, and he has actually given the link for them to check on the database. Thanks, Edward.
Thanks. Yeah, that's great information. Yeah, okay. So if
hello, Mr. Kang, may I ask a question?
Yeah, sure.
Hi, Ms. Chen, thanks for sharing. This is Guo Ching from NUS. So in our lab, we're also looking at using waste material as the so-called low carbon construction materials. But we realized that the usage of waste in Singapore as construction materials often under the regulations of NEA. So I wonder if public agencies like BCA and NEA has any channels to communicate with each other and together support the study of using waste material as construction material.
Yes, in fact, I think in the earlier slides that I've shared under the innovation section, the very good example is actually on New Sand. So this is actually an initiative by NEA because of the zero waste master plan that NEA has, you know, to actually divert the backfilling from Semakau landfill. So we have actually so-called collaborated with NEA to see how we can actually facilitate the use of the upcycled waste materials into useful building materials for use in our construction industry. So hence our innovation section is one place whereby perhaps, you know, those waste materials that are, you know, under the R&I or towards a higher TRLs, you know, so we can actually, we do have this platform whereby we have this BIP, the Building Innovation Panel. It's actually a one-stop platform that we actually help companies to actually clear the hurdles of, let's say they have some solutions or some materials that they want to, you know, recommend for adoption of. So we have this platform whereby we actually help the company to so-called try to clear the hurdles for the various agencies available. So that is one aspect. The other aspect that we have is actually the Built Environment Living Lab framework, BELLF, that was actually launched in September last year. So it's actually by our ministry MND. So for projects, right, they actually provide a test bed whereby you know, you have materials whereby you need to do pilot trials, etc. We actually facilitate with this provision of this test bed for the companies to be able to do trials, and also hopefully, you know, they can actually push for mass adoption subsequently. Yep.
Okay. Yeah. Thanks very much.
Thanks.
Thank you, Vun Ching. If there's no more question, shall we move on to the third speaker?
Okay, thank you.
Thank you, Vun Ching. Okay, let's invite our last speaker of the day, Mr. Engineer Joe Lan, Associate Principal of Arab Singapore. Joe Lan is Arab Singapore property business leader and experienced in managing high-rise, large-scale, multidisciplinary projects in East Asia region with a specialty in structural steelwork design. He is a local expert, having a track record working with international clients and world-renowned architects. He is holding a sustainability portfolio as Construction Declare's representative for Arab Singapore, promoting reuse of existing building and embodied carbon counting in projects. He has worked in Macau, China, Hong Kong, and in Singapore in the past 20 years. I hand over to Mr. Zhu. His topic will be how to reduce embodied carbon in building projects.
Yes. Everyone, can you hear me clearly?
Yes.
Yeah, I'll start. I know it's a Friday night. Last speaker is not very popular. I try to make it make a move so you guys can have a beer afterwards. Okay. So let me go to the next slide. Yeah, this is my agenda today. So We'll touch on why embodied carbon is important. Then when we talk about sustainable material, timber is always top on the list. I'll touch on a bit of that. Next is about if you don't use timber, what other measures can you use? And finally, just highlight some challenges and how we can overcome. So why is it important? I think because everyone's talking about it. This is a book I found recently, a library. You can see that even for gardening, they're talking about the low carbon way. But to be frank, back to the building industry, in UK, we understand that it's a call by the Climate Change Committee. They're promoting to regularize the whole life carbon in building projects. So this is might be happening in the near future. And while in Singapore, Greenmark 2021, if you hear just now that this is not compulsory yet, but you can count your whole life carbon assessment, which you need to include the embodied carbon for your building materials. And if you can achieve embodied carbon for this material load and a benchmark, you get points. So for us practice engineer, we'll see this might be getting to be compulsory in the future and might be tightening this requirement. Yeah, so it's important for us to embrace this now. So timber, we talk about its development, where it's going and what's possible. Give credit to my colleagues in UK, Andrew Lawrence. He's an Arab global timber expert. Most of the timber slides are actually a copy from him. Yeah, it's from him. So before 2000, timber mostly used for kind of lower rise building. But since 2008, the first kind of tall timber building happened in UK. And after that, you can see every few years it's getting taller and taller. I want to touch on what breakthrough happened in the past and make this possible. So timber actually, if you recall, it's actually been a large part of construction all the time. It's been common in landed property overseas, and it's for most of the lightweight frame. And the real breakthrough came in the 40s when there's use of waterproof glue to glue timber together to make it stronger. And this was used in the combat aircraft during World War II. It's light and strong, and you can actually, with the glue, you can glue smaller timber pieces together. Timber normally come in 5 to 6 meters long. And with this, the top left image is the finger cutter, and you can glue and connect timber together and make it longer elements. And there's a video here. Oh, sorry, I cannot play well, but actually there's a video showing actually the timber is going through this glue curtain and with resin in the front and the hardener at the back. So then you can actually glue this timber plank together and stay overnight to form glue lamp beam. Yeah. The next breakthrough is the invention of cross-laminated timber in the late 90s. It was relatively expensive during that time. The main reason is probably only a limited number of timber factories producing that. But I think in the past 8 to 10 years, more of these factories producing, so it became cheaper and cheaper. Yes, and this too, the CLT and glue lamp, actually, the invention helps to spread out the defects, average out the variability, making it actually 4 times stronger than the material itself. Yeah, making it a very good material for construction. The next breakthrough is your CNC machine. About 15 years ago, it was like only a limited number of factories got this machine, and it can cut timber very, very accurately, as close as 1 mm. And with this technology, actually, we can make this pavilion project in 2005 possible. It's because of the geometry, it comprises of 459 different pieces. And to be frank, you really couldn't do economically in any other material other than timber. So there's a video here which I can't play, but I just talked through. It's just another invention is the self-tap stepping screw to connect timber pieces together. It's quite easy to do. You can see there's a man there. You can actually drill in through quite quickly. And this stepping screw can actually hold a tension about weight of a car. So it makes the connection between timber quite easy here. And with this two technology like CNC and CLT, making building, you can do it like a flat pack furniture. those from IKEA. This the image show is a Smile sculpture in UK. It actually came in 12 pieces and then used a quite lightweight to lift and to can connect together with the self-tapping screw that I just mentioned. And the CLT make this first tall timber building possible. There's all the floor and the walls are in CLT. Yeah. And actually can be done now with bigger buildings. This is the Sky TV, the headquarter office in UK. So it is all in timber. And another merits of timber actually is, this is a video which I can't play here. Actually, it can be it's a time lapse showing the construction can be pretty fast and dry because all the timber material are prefabricated offsite. And it can be quite light, can be lift craned into place quite easily. And actually the project program for this project is from design to completion is 12 months and the construction of the timber frame is done in less than 6 months. So for timber, just compare the two projects. If timber material obviously is slightly more expensive in Europe than the reinforced concrete material, but taking into account of the time savings, the labor savings because of timber, and normally if you're timber building, you probably want to expose it, so you save the cost for the finishes. So actually in Europe, you could say for timber building, the cost is pretty much similar to a conventional reinforced concrete building. So this is a project Arnold is doing at the moment in Amsterdam, a 21-story timber residential building is coming. So with all this breakthrough technology, actually you can see we can do a taller timber building now. And when you try to use timber, it doesn't need to be just pure timber. This is just an example. You can actually do a hybrid structure, like what's on the image. You can do steel column, steel beam with CLT floor, which kind of can accommodate surface measurement better than a timber beams. However, the CLT floor is light, so there's some maybe vibration need to be taken care of. Alternatively, you can do something like this kind of timber concrete composite floor system, which have a similar performance than concrete structure in acoustic and vibration, but it's a lot lighter and easy to crane and install. So it's a prediction about what the future of timber. So if you do exposed timber structure frame that they can do about 8-story with school and offices. If you cover it for fire and acoustic purpose, with CLT walls, you can do about taller 12 stories, residential or suitable for hotel. If you do external tip structure, you can do it even taller. It's suitable for office because there's no wall inside. And if you do a hybrid system with a reinforced concrete core wall, wood floor, you can go even higher with other more variables. Yeah. So share about so good about timber, but why is it not popular in Singapore? There's a few projects been done here, but it's not like as happening as often as what we want. This is our observation. It's here it's expensive. The few reasons is no regional FSC supply. If you want to use timber based on the Eurocode, you need to make sure this is sourced from sustainably managed forest, which FSC is one of them. Obviously, contractor is not familiar with it, and especially they need to bring in a specialist subcon for overseas, so price may be a bit higher. The majority of people in Singapore are staying in a concrete building, so they feel solid and acoustically better, so they might need a bit of time to get used to it. Obviously, foreigners, they are quite used to timber building because that's what they're living in most of the time. There'll be fire restriction as well. If you have a timber building, it's more than 12-meter fire safety, you need to do a performance-based design. That means there might be some other measures you need to take into account. However, of all these issues, but I think we should promote this more. And how to promote? I think for your next project, you can, as one of the scheme, you can promote a timber scheme. It doesn't need to be a full timber. It can be a hybrid scheme for just for the floor, like what we mentioned just now. To give a client a choice. And obviously with clients actually looking for more sustainable development, with your help, we definitely will see more timber development in Singapore in the future. So then now jump a bit, also talk about timber, but more on the sustainably perspective of it, more about the embodied carbon. So the positive environmental effect of timber is quite obvious: lowest embodied carbon building material compared to steel and concrete, renewable, it's a carbon sink, storing carbon inside, biodegradable. The negative impact is if you over harvest in the forest, you will have deforestation and have impact to the local ecosystem. So to just touch on the embodied carbon of timber through the life cycles, you can just focus on the bottom left, bottom right image. Is from growing from a small tree all the way to a big tree. It we definitely need, for instance, to capture carbon inside it. So we call it sequestration of carbon. So the arrow going down means actually is having absorbing carbon from the environment. So we kind of got negative embodied carbon induced all through when it grows to mature. And then after that, you harvest it, you need to transport it, cut it, and all this use equipment and fuel and energy. So embodied carbon during this stage will go up. And then after you finish the material, construct the building, so that during the life of the building, the embodied carbon is pretty low. It's a little bit, it's not zero. You need energy to maintain it, and you may need to replace some of the broken pieces during the life, but it's pretty much quite negligible. At the end of life, that means you want to demolish the building. Then the embodied carbon will really, of that impact will really depends on how you're going to take care of the material after it's finished. If you put it into a bit of landfill, then it's the lowest. Why? Because you just need to transport it and dump it into the landfill. If you reuse it or recycle it, it will be slightly higher because you need to treat it, put it, and probably cut it again, transport it to erect for the next building. The worst is actually incineration, because all the carbon it captures through the life of it will be back to the atmosphere. So this is the worst. If you put what I just said into one diagram about the life cycle stage of timber, so this different color curve is the different way of counting embodied carbon, different rules, but you're just focusing on the red at the bottom. It actually just repeat what I said. If you count the sequestration of carbon in timber, you take into account the negative embodied carbon in timber during when it grows to the tree or the forest. During the manufacturing, obviously it increases, and during the life of the building after you construct, it's pretty flat, and it only and then at the end of life, it really depends where you put it: landfill, recycle, or incineration back to normal. So as another way of looking at an embodied carbon of timber is without any sequestration, like what here is in the blue. When you harvest, you didn't count the negative impact of it, just count when it started to be cut, harvest, and construct, and during the life of it. That's another way of counting it. So obviously, if you want to take advantage of the sequestration of carbon, obviously you need to take care of the end of life of it. Yeah. So carbon sequestration, what it really is, I want just to make it very clear. Doesn't mean you use more timber, the carbon sequestration will increase, because timber is from the tree. The tree is already absorbed carbon there. You use it or not, it's there. So use more timber doesn't mean there's more carbon sequestration. Sequestration is only temporary store in the timber. At the end, it will be eventually returning back to the atmosphere, depend how you treat it during the end of life. I think the only way to reduce the carbon emission is to plant more trees. And I just want to again put this in a different way of showing it. This is a graph showing the vertical axis is the amount of carbon absorbed per hectare for a particular forest, and this is time. So the green line is actually for conservation forest, means the forest, there's no harvesting, the forest is there forever. So you can see the embodied carbon, the carbon it absorbed actually is increasing a little bit, but it's quite flat. The pink line is a sustainably managed forest. And what it means is it manages how much tree you can cut for use as timber product. And after that, you plant back. So every time you cut something, you plant back, the new trees to grow, absorb more carbon. So a sustainably managed forest actually is good for the environment. You can see the amount of carbon they absorb is actually increasing. Obviously, the other way around, if it's not sustainably managed, you over harvest it, the carbon it absorbs actually will be lower than the green line. So last slide for timber, what should we consider? Obviously, you need to source it sustainably here. Second point is obviously to maximize the lifespan of timber structure. Try to reuse or recycle as much as possible. This second and third point actually not only is for timber, it's also applicable for any other structure. So when you consider timber, you need to consider cradle to the start to the end of life for both sequestrated and not sequestrated. So you probably have a better informed design decision. So, okay, we talked about timber for so long, but I've shared it's not as popular in here. So what other choices we have? So alternative way of low embodied carbon, there's a few points I want to share. One is we use a repurpose where possible. You try to compare embodied carbon for different schemes. We'll touch on the low carbon material, which is concrete and steel structure. Then anything we can do other than this, something in design fund we can do, and last with the challenges. So reuse and repurpose. In Singapore, this for heritage building, the yard didn't allow you to demolish. The only way is to repurpose. This is a project in South Beach. There are 4 conservation buildings there, and we work with the architect and the owner to repurpose it into a very nice, in the top left-hand corner is a very nice ballroom. And actually, there's a very nice bar in one of this conservation building. So you can imagine how much embodied carbon we save by not demolishing the building and not need to rebuild. And other than this existing heritage building, actually there's more we can do. We can do it for a high-rise building. This is a project example in Sydney. The developers intended to redevelop this building on the left. And the middle is the aspiration from the architect, what it looks like. The image on the right is a street view showing how amazing it is and how different it is from the existing building. So I think typical people coming inside would say, oh, let's demolish the whole thing and rebuild. But the team came up with an innovative solution. They demolished the red area, as shown in the left image, retain obviously the foundation, the core wall, and the perimeter column. And they just built the new part in green. Obviously, there's additional GFA for the developer to do so. So you can see with this thoughts, keeping the floor, the core wall, this foundation, so much embodied carbon they can save, and also giving you a new life is completely different from what you had originally. So this is a very good example to show us what can be done. Back home in Singapore, Apple Store and Marina Bay Sands, the left was the original nightclub. The owner decided to change it to Apple Store of a completely different shape. So this is what we do. We removed everything above water in yellow, and the image and actually the tunnel structure at the top we need to remove as well because the owner decided to make it wider. And then we retain the red part, all the soffit, the space slab, and all the foundation. We just rebuilt those necessary, those in pink structure, obviously the dome. And we have calculated after the project completed, we save about 3,200 tons of carbon. If you recall what Will said, 1 ton, one-way trips Singapore to Sydney, we actually managed to save 3,200 trips. So when you talk about reuse, repurpose, you talk to the client, promote, talk to the language of the client is talking about, share with them cost savings, you save money for demolition and rebuild, you save time for that. You can bring your development back to market quicker, cash back quicker. And obviously you can touch on the environmental aspect of it as well. So there's a lot of merits. Actually, the client should consider this. Next is compare embodied carbon from different scheme. This is just an example showing a 9 by 9 meter grid. The left is a pure timber scheme. And then this middle two is a hybrid timber plus steel scheme. And then it's a concrete and a structural steel scheme. I think we did this all the time with your client, showing different scheme, cost, headroom, etc. So now I think we can, with the tools that provided by Structure, we can calculate the embodied carbon per square meter for this scheme as another parameter for the client to consider. One thing I want to just suggest that in this, it doesn't mean steel gives a higher embodied carbon than concrete. It depends if there's a heavier load, it's a longer span. Sometimes steel will have a lower embodied carbon than concrete. So then what value should we aim for? Yeah. Greenmark already just shared that there's some benchmark for us to follow. The number at the table below is covering superstructure only for concrete, glass, and steel. Actually, in UK, there's a London Energy Transformation Initiative indicated some reference. You can see the image, the table on the right. Like, for example, commercial office, business as usual is 1,000 kg of carbon emission per square meter, and the target is to reduce it to 600 by 2020. So you can see Greenmark looks similar, 1,000, but if you look closer, it's quite different because the LETI's requirement is from A1 to A5, including substructure, superstructure, MEP, facade, and internal finishes. And that means you can see the Greenmark number, there's a lot of room for them to tighten. So we really need to engage and try our best to lower embodied carbon of the design we do now. I struck here on the left, that actually got some reference there. And Arab internally, we did have tracked some of our projects. So there's an Arab Carbon Insight showing projects and embodied carbon for different projects with different GFA. This is the rough numbers we got from the data we had. Yeah. Next, okay, we talk about timber. We talk about reuse. If you don't use timber, cannot reuse, then what can we do? Obviously, if the carbon and the steel we are using every day, there's a low carbon material that is available, then it's easy win for every one of us, right? So for concrete, the main driver for the embodied carbon is coming from cement, Portland cement. Obviously, you can replace recycled aggregate, but you can see from the bottom right table, actually the main contribution is cement. Aggregate contribution is not a lot, but obviously you still can do it. So the focus is always to minimize the Portland cement. There's a few methods to do: partial replacement using supplementary cementitious material. Second is a complete replacement of something different. And lastly is other technologies such as carbon capture. To categorize it, probably two main types: the ready-mix concrete at the top, use recycled aggregate or supplementary cementitious material. Typically, it can reduce 10% embodied carbon. It can actually reduce up to 88%. I'll touch in more detail in the next slide. Others are proprietary products at the bottom, various different materials. But the middle one, the carbon sequestration and cement reduction, which is for the product Carbon Cure, can reduce over 5%. This product is available in Singapore. The rest are yet to be available as far as we know. So this table kind of sum up different types of concrete on the left, and then this column showing the cement replacement and the carbon embodied carbon reduction achieved. Baseline is normal concrete we use every day. In Singapore Green Building Council, there's several ticks of concrete. The 4 ticks can achieve up to 10% embodied carbon reduction. Actually, you can go beyond 4 ticks. These are some of the mix you can find from the British standard BS 8500. It has cement replacement of up to 95%, which is about 88% carbon embodied carbon reduction. But this yet to be widely used here, and there's a few reasons as we can observe. One is with the lower cement ratio, the strength gain, curing time may take a bit longer. Durability, long-term effect of that need to be investigated further before it's widely adopted. So I think there's room for us to explore about this material and whether it can be used for our projects. Solar alloy and carbon steel material, embodied carbon steel material. Mainly is 2 areas we focus on. First is the material itself. If you from iron ore, from mining, a lot more energy is used to transport it, to mine it out before producing steel. Or you can use recycled steel, a lot lower embodied carbon. Next is the manufacturing process. Either it's energy intensive, basic oxygen furnace, or the other one is less energy intensive, electric arc furnace. This is a table just to kind of sum up again different type of steel on the left, and then the material in the furnace process, and then embodied carbon it achieved. So the type 1 is obviously the worst, 100% iron ore, basic Austrian furnace, about 2,600 kilogram of CO2 emission per tons it produce. Type 2, I would say is baseline because most of the material you get from here will meet this target. So using scrap metal, 95 to 90% scrap metal, BOF, so you can see achieve about 1/3 of the embodied carbon. The next step is using electric arc furnace. You can see another 40% reduction. For this particular material, you can get higher strength for this supplier. So if you're designing for this steel, using really need the higher strength, actually in short, you can get the low embodied carbon for free. And the last type 4 and 5 is actually the energy used for the electric arc furnace is 100% renewable, which means you can further reduce another 20%. Obviously, this embodied carbon value varies a little bit from different supplier, but this gives you a sense of what's possible for low carbon steel. So what's more? Obviously, we can do more just for design, maximize utilization. Instead of designing for a 0.8, 0.85, why can't we do it for 0.95 or 0.99? Interrogate the feasibility criteria. Facade engineer telling you, oh, your HB needs to design L for 300, if not my glass break. Let's have a conversation with them. Is it really needed? Because if you can reduce the limit, you probably have a smaller size, element size. Loading, heavy loading or what loading, think about whether we really need that heavy load. Can we reduce it or use a smaller loading? If the client is designed for space or for future use, not needed now for higher loading, have a conversation with him, explore with them whether it can be designed for lower, think about how it can be strengthened later on. So whether it's better for them to see whether that's the case. Reduce grid, the span, instead of 15 meter, can we do a 10 meter, 8.4, much closer, more efficient floor. Avoid substructure. If they want to do a basement, car park, explore course and program whether it can be cheaper, faster to do it above ground. Use cement replacement concrete, we touch on, it's an easy win. I think lastly is keep learning, talking and sharing like what we did today. So we can move together to a more sustainable built environment. I think the last slide here. Challenges is everyone tries to avoid to be the first mover. So I think all of us need to be more courageous. Obviously, with the information from BCA, from iStructE, you can probably give us some more confidence that we can go into this space. There's lack of low carbon material, yes, but you can keep searching, going if there's something available overseas, why can't I bring them in? They may be able to give you a discount price for your project to apply it in Singapore. So design, instead based on the norm, challenge the status quo, try to achieve lean design. Lastly, is clients always complain too expensive. To be frank, it's less supply and demand. If the more we adopt, the cheaper it becomes. Yeah. Okay, that's my end of the talk. Thank you.
Thanks, Joe. It's a very interesting talk and the coverage of various material from timber to steel and concrete, different ideas how to reduce carbon footprint. It's very interesting and very insightful. Thanks. May I invite anyone from the floor? Any questions for Mr. Joe? Joe, I have one question for the timber. For the timber structure, as I understand, current the market is generally the produce of the timber is from overseas using glulam or CLT transportation to Singapore. So the utilization there's a it takes a long transportation route. For local Singapore or nearby Southeast Asia, do we have such material can use similar technology, say, to use the local material like timber grow in Southeast Asia or even some say in bamboo, glue the bamboo together. Will there be any such material can use for the local market to reduce the transportation?
Yeah, so I did reach out to understand this. At the moment, as far as I understand, no. So everything needs to come from Europe, and I think a few years ago, one of the forestry in Malaysia is trying to. We understand they're trying to get a FSC certified, but at the end it's not successful. We don't know the reason why. But the answer in short is there aren't any FSC certified in this part of the world, and all needs to be shipped over from Europe. Yeah.
Oh, thank you. Thanks for the info. May I know any more questions from the audience? Okay, if not, I would like to invite, thanks all the speakers, Will, thanks Vun Ching, thanks Joe for all the insightful talks and very educative material. And I would like to invite our Vice Chairman, NUS Professor Pang Zitai, to give the concluding remarks for today.
Thank you, Chin Han, for being a very good MC for the evening. And first, thank you, Will, Arnold, for projecting a very powerful image on our minds on how real climate change is. But also at the same time, you share with us how much is in our hands to do something as civil engineers to reduce carbon emission. Vun Ching has shared with us a new policy that are driving the lowering of carbon emission, and also the case studies to demonstrate that lowering of embodied carbon and creating circular economy is possible. And lastly, Joe, for sharing with us the possibility of design with timber and how we can reuse or repurpose existing buildings to create something that is seemingly new and yet at a much lower carbon emission. And at the same time, also sharing with us the different options of low carbon materials. Lastly, this is only the start of an ongoing conversation on climate change mitigation. I hope that we all continue to play a part on this. Good night and have a nice evening.